Notice my definition of a square. A rectangle with two congruent consecutive sides. Where have we heard that before? Two congruent consecutive sides. Rhombus. Basically, we're taking a rectangle and applying a rhombus property. Okay? Ready to get challenged right off the bat, honors kids. Here we go. I'm going to have a separate definition now. Or, instead of starting out that definition with a rectangle, I want to start it out with a rhombus. A rhombus with, and I'm going to let you guys try to fill that out. If you have a rhombus in front of you, how do you make it into a square? What do you got for me? Think about it. If you have a rhombus, so rhombus, all four sides congruent. How do I make that into a square now? Think about properties that the rhombus doesn't have, that if I added them, it would make it into a square. Think you got it, Jack? Less than that. I don't need all of them. Just need one angle to be a right angle. Because think about it, Jack and everybody else. If that's a right angle, what's opposite it? And what's consecutive to it? Okay, so I only need one, that's why. So a rhombus with one right angle makes it a square. Everybody good? So I can have a rectangle with two consecutive sides congruent, or I could have a rhombus with one right angle. Properties of a square. Why do I only have two listed? Anybody know any properties of a square? Just rattle them off if you think. Go ahead, Riley.
All sides are congruent.
All sides equal. Yep. More. Oh, you're not writing that down, though. All sides equal. Let's keep going. All angles equal. Opposite sides parallel.
Consecutive sides are perpendicular. Perpendicular.
Forms the right angle, right? Yep. What are you guys just listing off for me? All the what? Parallelogram, rectangle. So numbers 1 and 2, all I'm going to write all rectangle properties. And all rhombus properties. Bottom line, everything we've discussed so far this unit, the square has. That's why it is the golden child. It has everything. The diagonals bisect, congruent, perpendicular, bisect the angles, everything, everything. All right, so we're good. Square, magical, I know, great. But can we use it in an algebra problem? One diagonal is 16. All right. So I got my little square going. 16. What's the perimeter? What did we just mention about the sides? They're all equal. So all you have to do is find one side and multiply it by 4, right? To get the perimeter. I'm going to hand this over to you guys now. Come up with, don't find it. Come up with a plan with the people around you how to find a side, knowing the diagonal is 16. You know all properties apply too. Get to it. Just don't find it, just make a plan. How could you find a side knowing the diagonal is 16? What's your plan? What is your plan? I've heard a couple of different thoughts. Anybody want to divulge their plan? 9, want to divulge your plan to find that side? Okay, I'm ready.
Diagonals bisect.
So you're saying draw on the other diagonal?
Yes.
Okay. I heard a lot of people say keep this diagonal and do Pythag, which is correct. Nothing wrong with that. Riley's saying draw in the other diagonal. Okay. What's happening now? Keep going.
Then the intersections form a right angle.
It's got all properties. Remember, that is a rhombus property, so it's a square property.
And then you can do Pythag on those triangles.
I need some values.
Sorry. Okay.
Right?
Yeah. It's each side is 8.
Okay. They bisect each other and they're congruent. So that's why this 16 gets turned into 8 all across the board. Everyone good there? And now we can take, yes, this right triangle here and perform the Pythagorean theorem. What are the A and B values? 8 squared plus 8 squared equals side squared. Got it. And you guys that I heard do x squared plus x squared equals 16 squared, that's still correct. Just got to solve it correctly. All right, here we go. 64, 64. Ooh, 2 64s. 128. Thank you. What are you going to do on each side to solve for x? Oh, but we are in what course? Yep. So I don't want a decimal. I'd like it in simplest radical form. How about that, Nick? Huh? Simplest radical form. Can your classmates handle that? Good talk. All right. Well, honors kids, what are you doing? You're getting out your calcs to find the biggest perfect square that goes into 128? You already found it. You did the work already. What's the biggest perfect square that goes into it? 64, yeah. Times 2. So one side, not the perimeter yet, one side will be 8 radical 2, yes. One side will be 8 radical 2. So you want to find the perimeter? We already said I take one side and multiply it by. I thought kids' heads were going to explode when I asked them to do this today. 8 radical 2 times 4. No decimal. I want it in radical form. Kids are like, what do I multiply? What do I multiply? All right, come on. Be tough here. 1, be tough. What can I multiply up there?
The whole number, not under the radical.
Correct. Good words. So which two numbers am I multiplying?
8 and 4.
To get?
To get 32. Radical 2.
All right. Remember, you can only multiply a radical with another radical. That's it. Okay. Nice job, kids. Not bad. All good. All right. We still need a heck of a lot of more practice on our coordinate proofs. I don't know if you guys are feeling comfortable or not, but I got to make sure these things are organized and you guys have the correct info in there. All right, you ready? What am I asking you to prove this? It is a square. Okay, so what would be good enough to show it's a square? Ready? Would that be good enough just to show it's got a right angle? I got a square. Just one right angle, that's it? Nope, right? Is that a square yet? Because right now it's just a quadrilateral, no properties. Is that a square? Square? Not yet. What is it right now? Rectangle. Now it's a square, or square yet? No, what is it? Square? Now it is. Which way are we going to do? Do we go rhombus, right angle, or do we go rectangle, consecutive sides? Okay, you got it. Rhombus, right angle. Here we go. Everyone all right? You can do both ways. Rhombus, right angle, or you can do rectangle, two consecutive sides. All right, so if you're going to do rhombus, how are you going to show it's a rhombus? All four distances are equal. All right, so here we go. Distance of PQ first. Showed you guys my cheat code yesterday, also known as Pythagorean theorem. 1, 2, 3. How are we doing? We getting down to the square root of 25, which is also known as 5. Now, hey, I understand it. Some of you guys get a little frustrated with me because of how much work I asked you to show. But once you find the first side is 5, you cannot just go and say the other 3 sides are 5. You need to show me where that 5 came from. Okay, you know it's going to be 5, but show me where it came from. So here's what I'm like. You can't just automatically, oh, RS is 5, PS is 5. Where did the 5 come from? Show the work. You don't need to show me all steps. At least show me what you're plugging in, and then you can say equals 5. So you guys keep trucking with the distances. So everyone getting out 5. All getting out 5. We're all good. Okay. Step 2 is not telling me what type of figure it is. Step 2 is telling me what you found out from your formulas. You did not find out that this was a rhombus yet. What did you find out about PQ, QR, SR, PS? They're all equal. They're all congruent. So that is step 2. All right, you're telling me these are congruent. You guys are telling me these are parallel, maybe. Maybe the diagonals bisect each other. You are not telling me in step 2 that it's a rhombus, parallelogram, rectangle, square. So you're telling me QR congruent to PQ, congruent to SR, congruent to PS, and then you're going to tell me why? What's a good why here? Why are they all congruent? Yeah, come on now. 4, let's roll. Yeah, thanks. Distances are equal, right? Now what is it in step 3? Now that all 4 sides are equal, this is not a square. We said that it wasn't a square yet. It was a rhombus. And hopefully we're keeping this all in nice order, labeling your steps. PQRS is a rhombus. Why is it a rhombus? Oh, what happened to my numbers? Oh boy. Come on, there we go. Can I do it? 17. Why is it a rhombus? You had a 1 in 100 chance, Patrick. How special do you feel now? That's special. Okay, good. Good. You guys are just chatting it up with me here today. And what do we say we need to add to it to make it into a square? Right angle, which means I need what formula? Slope. All right, you got a big job here. How annoying is this? Good. I'm going to keep doing it. 10. Big job. What angle do you want to show as a right angle? Angle Q? Okay, so that means I'm going to have to find the slope of which two lines there, Nick? PQ, and then find the slope of QR. Yep. You guys can just use rise over run. If you want to use the y2 minus y1 over x2 minus x1, you can. PQ, I'm going to ask for somebody for PQ first. Up and over how many? 81, 86. 4.
3/4.
Up 3 over 4. Did you happen to get QR, young one?
Yes.
Okay.
-4.
Proud of your boy there, Isaac? Proud of your boy? You guys all right that you're separated now? Or are you guys still sending energy each other's ways? I could see the big grin on his face. He was happy for you. Yep. Everyone all good? Oh, got some characters. What did we just find out? No, it's not a square. It's not even a right angle yet. That PQ and QR are perpendicular because slopes are negative reciprocals. Now, Nick, what do you have at your angle? Oh. At your angle Q, what do I have now? Thank you. Why, Nick? Oh, unbelievable. And now what is it finally? The square. I'm interested to see why it's a square. Somebody's going to tell me. Why is it a square? Details, details. How fun is this, kids? 19? Why is it a square, Maya? Look at all the work we just did. Make it match. Okay, basically it's a what? Because it's a rhombus. Ooh, we didn't say that though. A rhombus with? There you go. Good. Use the work you've already done. Deep breath there. How about that, kids, huh? That was good, Kellen, wasn't it? That was solid. How you guys feeling about these coordinate proofs? We all right? Easy points, I feel like. Easy. All right, you ready to go on to the outcast? The black sheep. of the quadrilateral family.